Okay, now we are talking about spicolature. We start from two cases in which two great mathematics, as Giambligo say, that Ippocrate di Chio and Ippaso di Metaponto, they were, I would say, scatched. They were getting out from the confraternity because they say to everybody their own secrets. The first secret is how you can build a pentagon, and the other was because the construction of dodecaedro. Okay. They say why this was so important, because to provocated this event. It's very easy because the pentagon is built between the geometric relation through the diagonale and the side. It's irrational, so has no logic. In the meaning that you cannot measure if you have just a relation between arithmetic interi numbers. Okay, so it's something very apart. The demonstration of this irrational thinking between the diagonale and the side of the pentagon, it's very intuitive. You know, it's very kind of animal when you are intuitive. And it's getting from the consideration that these figures are coinvolved. The diagonal of the pentagon, they are formed one star, Pythagorean star. You know, like the Jew star. Okay, you have just pitch in your mind this star. Okay. In between, in the center of this is a pentagono regolare, okay? Pentagono, in which the side is the difference between the double of the side and the diagonale of the pentagono from where you start on this, and which the diagonal is the difference between the diagonal and the side, okay? If the side and the diagonal of this pentagon they were measured from someone, they was measured also from numbers that are interi numbers, more little of the numbers before. And because of this, you will get infinity of decrescent, that going down of interi positivi, and that it's impossible. The most important relation between irrational is because between the diagonal and the side of the fourth side del quadrato, even if the demonstration in this case less intuitive. The figure of the Menone of Platone is getting through these arguments inside of vierkante, big, and a little quadrato, in which the diagonale is the same to the side of the one before, but in which the side is the same on the half of the diagonal. So this is a technically specific arguments, but in this time I advise you to get deeply to these arguments, because mathematics, it's not something that you can study so in a very easy way. You gotta go deeply. So get through to this. So he followed saying that the half of intero, the number intero, is intero only if the intero of from which you start is pari it's like that. The geometric argumentos is got to be supported from also from a point of view of arithmetic arguments, in which the first proof, the testimonianza, the proof is you can find in the numbers primi analitici from Aristotle. And Aristotle gives a demonstration in any way that in autonomy way the irrationality of these roots is number 2. So in one side, because of the ancient and the demonstration of this irrationality was a scandal, for us at this time they are the anticipation of a great modern result. And first of all this is il principio di indeterminazione di Heisenberg. So the principio di indeterminazione di Heisenberg. So go deeply on this. I can follow because the recording is still good. My voice is a little bit better this morning. I guess I should do the conversation in the morning, and you see how the morning and the night can also give you some physical answer to yourself and to your body, also the way of thinking. But it's better that I don't say nothing, because I get from the shadow here behind a booth, a retacap. So in this case, in this lesson, we are talking about two things, about Euclide and the booths behind your head. They are parallels. You see how life goes parallel. So the life also, the meaning is how less booth, a retacap, as a pupil you get during your life. And I must be sincere, I took a lot of booth, a retacap, and I'm still getting booth, alright, behind my head. But never mind, we go on. Aristotle said that irrationality of the roots of number 2 is give the fact to it's not possible to measure in the same time two interi numbers in the same time. The lato, the side, and the diagonale of the four side, il quadrato. One measure, the whole measure of the side, get out another measure of the diagonale, and in a way opposite. Physics say that side and diagonale, they are orthogonal grades. I mean, they are, measure, sono grandezze ortogonali nello spazio delle fasi. Because for the mathematics, they were construct only one corner or 45 degrees in the Euclidean space. In a more complicated way, the demonstration of these irrational roots of 2 you can see also as anticipation in the work of Gödel, Teorema di Incompletezza. Okay, I follow. And now I discover also many things about X and Y and writings to someone that you seems to know, but its first concept is because the formula for every X and Y, the quadrato of X, it's not the same as the double of the quadrato of Y. If we make interpretation of entire numbers, the formulation is true, because on the roots of this thinking, number 2, it's not rational. But if we see this from a point of view in which the numbers are real, then the formulation is not true. So the matter is from which point of view you see the things, and see how this is very, very important since the ancient time. So you just have to take x as the roots of number 2 and take y like number 1. And so you have the perfect formula. It means that no the formula and no the negation, they are demonstrated in a system that can show you only the trueness, the common truth between integer numbers and real numbers. In other words, wherever system you use, it must be incomplete. So, you see, even the mathematics, it doesn't has to be perfect. And this is very strange, no? Because you think always that mathematics is logical. But Gödel say that this example, and he extend this to all the systems that demonstrated only the truth on the integer numbers. Let get out, or you say, no, I don't want to talk about what is in reference to the real numbers. With a big difference, that you cannot anymore give an example, just one example, just an example that is always good, that it works once for everything, because any arithmetic formula is true or not true for the integer numbers. Dunque, or the formula or its negation, they can have the function to be a system that gets the demonstration only for the truth. What Gödel tried to say is that you have to find for a system, or we have to find a system, a formula that the system doesn't decide, in the meaning that it doesn't exist, not even the formula and not even the negation about this. So it's an encounter about these two ways of thinking. And this way of thinking has maybe to do with the way, the natural way in which in the 1900s they were thinking. The fact that the theories, scientific results, the more important scientific result, they can bring you to the extreme consequence, a irrationality that from the first instance was really make problems to the ancient Greeks, and then that's the question. So I repeat this in Italian because it's a very important concept, and concert maybe, because concert is also important. Concept and concert, because the music also has a lot to do with the mathematics. You see, in the music you have a lot of fraction numbers, a 4/4, a 4/8, 16/8, but this is not only. This is a small example. In the music you have a lot of also the way of the thinking of composers. From the great composer from Bach, Mozart, you see a lot of mathematics way of thinking. But that's the combination between the composer of music is a compromise between rationality, so time and perfect of being together of the notes, and the creativity of making a new harmony, a new pieces. So I will suggest you to go to listen back to Bach, Mozart, and first you should start with the middle music. It's Palestina, and all the big composer until 400, and then 500, 600, 700, 800, 900. They are also important. I'm talking about classical music. That's the point. Okay, I guess the convention is finished. I want to say Thank you to everybody, and I hope that to see you the next time.